Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for class 11 CBSE applied mathematics. So in our previous sessions we have already completed the topics majorly from quantitative aptitude. So if you see our previous sessions, we have seen the topic clocks, calendars, and also we have completed the topic average. So all those topics we have been seeing from the very basic concepts, and also we worked out very good example problems also. And recently in our previous session we have completed the topic indices, and also there also we worked out problems. And following these topics again we are going to see another new topic from quantitative aptitude, and we are going to start with the topic time and work. And this session is going to be the first chapter, chapter 1 of this time and work. And this session we are going to start with a very basic, very important concept of time and work. And of course we are going to see two basic important things. Of course they are going to be the fundamental of this time and work chapter itself. So such a thing is what with which we are going to start here for this session. So yes, let's get in. So the things we are going to start with is manpower and time. And second thing is manpower, time and work. So these two things are what we are going to discuss here in this session. And also along with that we will be working out some example problems based on this concept. That is going to be the objective of this session. So before that, first of all, in this time and work chapter, what kind of problems are all we will be getting? Have you seen problems before? So if you see this time and work chapter, you will be able to see problems based on some team of people are working on some assignment, and they are taking this much time to complete the assignment, And what happens if the team is going to, or if the team is going to have more number of people or less number of people? Likewise, you will be having the question. Or otherwise, if the team should be assigned to complete the work in this particular time, within this deadline itself they have to complete the work, then what happens? Then how much time it will take, or how many people do they require in order to complete the work? So these kind of problems you can see under this time and work problems. And next, what are the other varieties of problems you will be getting? You may even able to see problems based on individuals, like there are two people or there are three people like A, B and C. So A can complete a work in this many days, B can complete the same work in this many days, C can complete in this many days. What happens if they all work together? Then how much time it would take for them to complete the work? So this way you will be having problems, and there are many varieties also. So what happens if they work in alternative days, or what happens if they work in pairs, two people at a time? Many varieties are there. And last is you will happen to get some application problems, like you will be getting some problems based on pipes and cisterns. This pipes and cisterns is actually going to be an extension of this time and work only. Okay, fine, yes. So with this concept as the beginning, we are going to start here this chapter 1. So as I told, we are going to start with manpower and time, manpower, time and work concept. Yes, let's start. So in order to begin, let's start with manpower and times comparison. That is, if there is some work is to be assigned, there is a work that is to be assigned for a group of people, let's say a team, a manpower, and let's say that they are able to complete that work in some particular time. Is the thing clear? So there is some work assigned and a team of people are going to work on it, and that team is going to take, or that manpower is going to take this much time, some particular time to complete the work. Now think of what happens if the manpower is going to increase, or what happens if the manpower is going to decrease. We will just think of both the cases, okay? So if some manpower is going to work, they are just taking this particular time to complete the work. This is our assumption. Now what happens if the manpower is going to get increase, or in other words it can decrease also, right? Both the possibilities are there, right? Now what happens to the time? That we have to think. This is very basic, okay? We can easily sense this, right? So some particular team is going to work and they are able to finish in this much time. But what happens if the manpower is going to increase? If you are putting more people into that group, then what happens to the time actually to complete the same work? Remember, the work that is assigned is the same. There's no change in the work. You are not touching anything there in that work. Work is the same, but the manpower is only getting changed. So when the people is going to increase, number of people, I mean the manpower, if it is going to increase, what happens to the time? Obviously, the time taken to complete the work will be decreased. That's the logic, right? Because if you have few people, they can complete in this much time. But if you assign more people into the group, then what happens? The work will be happening in a faster way, right? Yes, because the work will now happen in more efficient way, so that it will take lesser time to complete than compared to the original case. So when the manpower is going to increase, and in that case what happens to the time here? Time will decrease. Same way, the other way, what happens when the manpower is going to decrease? Then what happens to the time? Now this time will be increased, right? Yeah. Why? Because if the manpower is going to reduce, I mean if you are going to decrease it, if you are going to lessen it, what happens? There will be only fewer people now than compared to the original. So that means what happens? It will take more time for that team, the smaller team, to complete the work. I mean the same work what is assigned originally, right? So this is going to be a basic logic, and this is how now we are going to get a relation between manpower and time. I hope you will be very clear about this relation. So you are comparing two quantities, and in that case what happens is, if one of them increases and the other one is decreasing, or if this one is, the first quantity is decreasing and because of which the second quantity is increasing, then what do you call? Then what relation is there between these two quantities? Yeah, you call it to be inversely proportional. Is it or not? Yes, we know that, right? So inversely proportional, that's the only point we have to keep it in our mind now. So when manpower and time, so when a work is going to be a constant, or if the work is going to be a fixed quantity, then what happens is, manpower and time, these two quantities are inversely proportional. That we have to remember. Okay, so manpower is inversely proportional to time. So this is how we represent it, right? So in this case what happens is, we can even write it as manpower is equal to some constant times 1 by t. I can write it like this, right? Where that k is some constant, and if I bring this t to this side, to the left hand side, what happens is, manpower into time is always a constant, right? Okay, so this is the very important thing that we have to keep in mind. So manpower and time, their product, I mean if I multiply them, I will always get a constant. This is what we have to always remember. Why? Because they both are inversely proportional. That's the relation. Yes, this you have to keep in mind. And manpower and time, manpower into time is equal to a constant. This product is equal to a constant in the sense, for a fixed work it is going to be constant. And second thing is, that work is a fixed one, and in that case whatever value your manpower is going to take and whatever value the time is going to take, whenever you multiply them, for a fixed work I am telling, whenever you are going to multiply both those values, they will always give the same value. I mean the product you will be getting, right? That product will be always the same. That also you have to understand. So that means I can even write it as M1 T1 will be same as M2 T2, will be same as M3 T3, and so on. And what are these values? They are what is equal to that constant. That's it. Okay, so this point you have to remember. Why I am insisting this point also is, it is very important for us when we try to solve the problems. That's why. Okay, so just remember both of these equations or both these results. Just be careful with these results, because we will be very often using these results when we come to try to solve the problems. That's why. Yes, fine. So it's the first concept. I hope it is very clear to you. Manpower and time, what's the relation? They both are inversely proportional for a fixed work. Okay, I can even write it above so that it may avoid the confusion. Okay, when given the work is a constant, given the work is a constant, then always manpower and time are inversely proportional, and hence what happens is their product will be a constant. That's it. Okay, yeah, coming to the second part. So second, another important thing is the comparison between manpower, time and also work. Now what happens if all the three are going to vary? Okay, now all the three, what's the relation between all these three values? Now the first case is, we assume the work to be a constant, There we compared manpower and time. Now the second case is we are comparing all these three. Now let us see what happens. Yeah, fine. So we already know the relation between this manpower and time. And now let's try to get a relation between this manpower and work. Right? Okay. So what I am going to do is, in order to get a relation between all these three, I am going to take manpower and time first and manpower and work next, so that I can clearly get a relation between these two and this two. Now that will help me to get a derived thing. That's it. Okay. So we already know that manpower and time are inversely proportional. So when I come to compare manpower and time are inversely proportional. This we know. Now second thing, let's come here. Manpower and work. So that is when a group of people are going to work, and now let us fix the time. This is when manpower and time I am going to compare when the work is constant. Now this time what I am going to do is I am going to compare manpower and work. I will take time to be a constant. When I keep time to be a constant, let us see what happens to manpower and work. Right? Okay. So when you have a group of people, they are going to work for some particular time. Say some 5 people are working. If 5 people are working, they can complete this many work. Let's say if the manpower is going to increase. Manpower is increasing in the sense, what do you mean? If the size of the number of people is in the group that is going to increase. Say some 8 people are there or 10 people are there. Now 5 people can complete this many work, and now 10 people are there. Then definitely the 10 people now will be able to complete even more amount of work. That's the point, right? Because they work for the same time, and in that case what happens is, if 5 people can complete this much work, then 10 people can complete even more work. That's the logic, right? Why? Because manpower has got increased, and as a consequence work will also get increased for the same time. And what happens when the manpower decreases that time? So if 5 people, in the place of 5 people, now there are only 3 people. So 5 people can do this much amount of work, then 3 people can do how much work? That work will also get decreased. So this case what happens is, when manpower increases, work is also increasing, and manpower decreases, what happens? Work is also decreasing. So this case, how do you call the relation between manpower and work? So it is very simple for us to understand. Manpower is now directly proportional to work, because both the sides it is increasing or both the sides it is decreasing. This is what is happening, right? So they are in the same way. So this means that's a direct proportion. I mean, manpower and work are directly proportional. That's it. Okay. Now we are very clear about manpower and time relation, manpower and work relation. Let's put them together. Now let's see what happens. Now what happens is, manpower is directly proportional to work by time. I can conclude like this, right? Right? Yes. See here, manpower is proportional to 1 by T. Here manpower is proportional to work. Now what happens is, I am putting both these things together. Manpower is proportional to this W by T. I mean work by time. That's it. Okay. Now in order to just take out this relation, I can equate it to manpower is equal to some constant times W by T. This way I can conclude. And second thing, if I want to keep this constant alone on the right hand side, I can bring this W by T to the left hand side, so that it would become M into T by W. Why? Because my T here in this denominator will come to the numerator's position now, and W in the numerator here will come to denominator's position in the left hand side. So this will be equal to some K, I mean a constant. Okay. So now what is the relation between all these three? Then our answer should be manpower into time by work is equal to a constant. This point you have to remember. And similarly, how we derived here, I mean how we came to a conclusion here, the same way here also we can even conclude. So when we have 3 quantities, manpower, time and work, all 3, then definitely manpower 1 by time into time 1 by work 1 is equal to M2 T2 by work 2 is equal to M3 T3 by work 3, and so on. And again, why I am giving this is, again, this will be again useful when we do solve the problems. That's why. Okay. So take down these results very importantly, because they are really important for us to do the problems. Okay. And just remember, when work is a constant, manpower and time, they both are inversely proportional. So in that case, manpower into time is a constant. And when manpower, time and work, all these 3 things are given, all 3 are varying, then that time how can we link or how can we relate all the 3 quantities? They can be related by manpower into time by work is equal to constant. That's it. Okay, so take down these two conclusions, important results, and now using these results, let's try to work some example questions. Here is our first question with us. We'll see the question. If 18 men can complete a work in 25 days, then 15 men can complete the same work in how many days? This is our question, a very simple basic question we have. So it is very clear that by reading the question itself, it is very clear that this question is actually a comparison of manpower and time only. Yes, okay. So let's take the data whatever which is given to us. So we actually have men and time compared here. So men here and time which is compared here. Actually the time is given here in terms of days. That's the only thing. So no problem with that. So let's take the data what is given to us. If 18 men can complete a work in 25 days, that is a team of 18 men can complete a work in how many days? 25 days. Okay, so 25 days. So 18 men, time, under the time I am taking 25 days. So this is the scenario. And what next is given to us? Then 15 men can complete the same work in how many days? That's all. So 15 men. Our question is then 15 people can complete the work in how many days? This is our question. Very simple. Okay. Yes. So we very well know that manpower and time are inversely proportional, and in that case their product is a constant. We know that always whenever I multiply them, they will be always a constant only, right? So we can even take it like this one to be our men 1 and this is our time 1. I am taking this to be M1, this to be T1, and this will be our M2, and we are supposed to find what is the value of T2. That's it. This way we can assume it will be helping us to get the answer, and we clearly know the relation, that is they are inversely proportional, or in other words, how we even concluded? We concluded as M1 T1 is same as M2 T2 is same as, and so on. This is how we compared, but here we have got only two scenarios, only two cases, right? So our comparison is enough. That's it. So let's now substitute the values. So M1 is 18 into T1 is 25 days, so 25, which is same as M2 is 15 into time 2, that number of days is what we are supposed to find. Okay, so let me do a thing. Let me take this value to be some x. So 15 into time 2, according to our assumption it is x, right? So now x will be equal to, just bring this 15 here to the left hand side. I mean, like, we'll take this to the other side so that it will come as a divided by 15, is it or not? So x will be now equal to 18 times 25 by 15. That's it. Now when we try to simplify this, we'll be getting, so I think we can cancel this 15 and 25, both are divisible in 5 tables, right? So this is 5 3s are 15 and this is 5 5s are 25, and again this 3 and 18, we know that 3 6 are 18, so that means we have got 6 into 5, 6 5s are 30, that means x is equal to 30 days is our answer. So time 2, I mean 15 men, this group of 15 men will be able to complete the same work in 30 days. So answer for our first question is 30 days. Let's work the second question. So question with us is, given 24 boys can complete a work in 55 days, then how many additional number of boys? So let's be careful with what words they have used there. So be careful here. Then how many additional number of boys? Okay, additional number of boys are required to complete the same work in 40 days itself. So this is going to be a question. So again, it's very similar to the question that we have worked previously, I mean the first question. So this is again a question which is based on manpower and time comparison only. So manpower and time. So this is also a question that compares manpower with time. Yes. So again, as usual, let's take the data here. So given 24 boys can complete a work in 55 days, right? Okay. So here the manpower actually is in terms of boys and time is in terms of days. That's it. That's the only difference. So manpower, so 24 boys can complete a work in 55 days. Okay. So 24 boys. So I'm just writing 55 days. 24 boys can write 55 days. Just ignore about that boys, days and everything. Okay. Let's not confuse. So manpower is 24. Time is like 55. That's it. Okay. And yes, continue the question. Then how many additional number of boys are required to complete the same work in 40 days? So this time this second manpower is missing. I mean, how many boys? I mean, that number of boys is actually missing. can complete the work in 40 days? That is the question. Okay, so how many of them can complete the work in 40 days? That is the question. So that means here in this case, this M2's value is actually missing, and we need to find this value in order to get the answer. Okay, yes, fine. So as usual, so the same relation, manpower and time for a fixed work, because the work is going to be the same like previous question. So when the work is same, manpower and time, they both are going to be actually inversely proportional. And as usual, what we are supposed to do, we can take this as M1 T1, and we'll take this to be M2 and T2, and as usual this is missing. Let me take this value to be X. Yes, ready? Fine. Okay, so M1 T1, I mean 24 into 55 will be same as M2 into T2. Let me not repeat writing the same steps, okay, because I hope you are able to understand it. M2 into T2, so X into 40. Let me directly write the equation itself. You can fill the previous step. Yes, continue it. So 24 into 55 is same as X into 40. Yes, that's it. Now, in order to find this value of X, we have to take 24. X is equal to 24 into 55. I mean this 24 into 55 divided by, let me bring this 40 to the other side. So this becomes divided by 40. Hope it is clear. Now let's simplify this. So we can just cancel this 24 and 40, right? Because both are divisible in 8 tables. So that is 8 3s are, this is 24, and 8 5s are, this is 40. And once again this 5 and 55, these both are 11 times, because 5 11s are is 55, right? So we are ending up with 3 11s are. So that means X is equal to 3 11s are, it is 33. So X is equal to 33. That means we require 33 boys to complete the work in 40 days. Yes, fine. But is 30 our answer? Be careful. Be careful with what is asked in the question. We are not supposed to find how many people are required to work, I mean to finish the work in 40 days. Be careful with the question what has been asked for us. Then how many more additional, I mean how many additional number of boys? So how many more number of boys are required? That is our question, right? So previously 24 boys were working, and how many additional people we need? That is our question, right? See here, X we are getting the value to be 33. That means here in order to finish this work in 40 days, we require 33 boys. That is okay. But question what they are asking? They are asking how many additional number of. So additional number of boys will be now equal to, here originally there were 24 boys, and now we require 33 boys to complete the work in 40 days. But question is how many additional boys? So that means how many extra boys are required? How many more people are required here? So this new 33 minus this original 24, I have to subtract it, so that the difference will give me the additional. So this will be equal to 9. So that means we need extra 9 boys. I hope it is clear to you. We need additionally 9 more boys to be employed in order to complete the work in, I mean the required task in 40 days itself. So additional number of boys is equal to 9. 9 is going to be the answer for this second question. This is our last question of this session, question number 3. Our question is 6 kids can eat 6 cakes in 6 minutes. Then in how much time 15 kids can eat 35 cakes? So very interesting question. So you would have seen this question very commonly, and this question is what now we are going to work out with the concept that we have seen earlier. Yes, fine. Now if you see this question, they are comparing this kids, they are eating some cakes, and how much time they are taking in terms of minutes. So if you see very clearly, they are comparing manpower. That manpower here is like kids, and cakes is that eating cakes is going to be the work that is being completed, and the time taken is given in terms of minutes. That's it. And now let's take the data whatever is given here in this question. So how many kids are there? 6 kids are going to eat how many cakes? 6 cakes, and they are taking 6 minutes. So everything is 6 in the first row, and our question is then in how much time, that is in how much time. The time is missing here in this second case. 15 kids can eat 35 cakes. So 15 kids, they can eat how many cakes? 35 cakes, for which how much time they would take. This is going to be the question, and this question is actually a comparison of manpower, work and time. So we have to carefully remember that also. So as usual, let's take the values to be M1 here, and this is going to be work 1, because we have just discussed manpower is like kids here, and eating cakes is going to be the work here, and time is in terms of minutes here. So time 1, we'll take it like this, and here this will become M2 is like 15, W2 is our work 2, which is 35, and T2 is what we are supposed to find, and let's take it to be some X. And just remember, just clearly remind that relation between manpower, work and time, how we related them. So we have the relation manpower into time by work is equal to a constant. You can even rewind this video and see there. So manpower into time by work, that is what is equal to a constant. In other words, how we have seen that M1 into T1 by W1 is same as M2 into T2 by W2. Okay, since we have only 2 cases here, it's enough if we write 2. Okay, just 2 cases, just for 2 cases alone. And let's just substitute the values now. So M1 here is like 6 into T1 is also 6 by W1 is also 6 is equal to, come to the right hand side now. So on right hand side we have M2, which is 15 into time 2. Time 2 is what is we are taking to be X, divided by W2, which is 35 for us. And yes, if possible here itself we can simplify. So I can cancel 1 6 with other here in the left hand side. And if you see this right hand side, we have 15 and 35, that also we can cancel, right? So we'll be able to factor out 5 from both. This is 5 3s are 15 and this is 5 7s are 35. And so in the right hand side we have 3 into X by 7. And now in order to find the value of X, all we can do is, we have only 6 here in this side. So 6 into this 7 will come here on the numerator, and this 3 goes in the denominator position. So we'll end up with 6 into 7 by 3, and finally we can even simplify this. 3 2s are 6, so 2 7s are 14. So that means finally the value of X is equal to 14 here. So that means how much time? X is equal to, the value of X is 14, and we have our times value given in terms of minutes. And so answer for this third question is X is equal to 14. I mean 15 kids can eat this 35 cakes in 14 minutes. If you want, I can even write here 14 minutes. So 14 minutes is the answer for this third question. Yes, all of you, I believe that you are very clear with all the strong basic concepts that you have seen here in this chapter 1 of time and work, and also you are clear with the problems, the 3 problems that we have worked here. And any doubts you have, you are welcome to post in the comment box, and if I see them, I would definitely help you in rectifying those doubts. And yes, very soon we'll just catch up with the extension part, I mean the second chapter of this time and work, as early as possible. See you soon there. Thank you so much.